Hi, I'm Davin Loma. This is week 2 of the online summer learning program. Today we're going to be talking about three-dimensional shapes. Three-dimensional shapes. You will need 6 pieces of paper. I've got it's not all that good right there. We're going to wind up doing something with these pieces of paper, but you need a total of 6 of them. So you need to have 6 pieces of paper. So have 6 loose pieces of paper, and you're going to be building something with that. Actually, we're going to be building a cube before we're all said and done. But before we get into that lesson, I think we need to wind up looking at a different picture so we can talk about different things as far as geometry and how we can see different mathematical items and terms as we go through our environment. So let me get that up for you in just a second. All right. So again, as we go around, we'll see different things that we can see. I notice that there's a picture door there. It looks like it's a little bit of an older door. And if you notice, I see all sorts of different shapes there. So let's just take some boxes there, kind of leaning. It's like how I would carry things. So the first question that I have about this is describe how you might find the area and the perimeter of one of the rectangles in the picture. So how would you find the area of one of those in the picture? Now, I would probably use some type of a ruler. I don't know if I can spin that around. Can I spin that around? So if I had a ruler somewhere, I could wind up measuring it. I don't know if inches. I normally measure things in inches more than other things, but I would need to measure, like if I was to be measuring this square right there, that rectangle, not a square, a rectangle. That's pretty close to a square. I would need to measure it, and then I'd need to measure an adjacent side just to double check that they were actually what the measurements were on it. Notice how that's giving me a 90-degree angle. So to figure out the perimeter of the shape, that's the complete distance around. So I'd need to go all the way around that shape and figure it out. So I would add all the sides together. To find the area, I would need to multiply 2 adjacent sides. So I mean, if I picked, oh wow, that got really small. If I picked this side, I would need to have this side or this side. And you know what? Opposite sides have the same length, so it doesn't really matter which one you have. So I would use, probably in real life, I'd probably use a tape measure, and then I would measure the side lengths of it to figure that out for that. Let's see if I can get rid of, can I get rid of that tool? All right, let's zoom out and see what other questions we can have there. So for perimeter, it's the area around. For the area, you multiply 2 adjacent sides. And the next one, where do you see parallel and perpendicular lines? So parallel, the thing that I like about parallel is actually, if I zoom way into that, I don't know if any teacher has shown you this before, but if you look, right there, that gives an example of parallel lines right there. And the word parallel, I'll zoom back out. So parallel lines, there's tons and tons and tons of parallel lines. Maybe I need to make that a little bit smaller. All right, so I mean, parallel lines almost, is it all right if I say they look like railroad tracks? See, railroad tracks. And if you notice, like, Although I'm not drawing those perfectly, like all of those are going to be parallel to each other. And perpendicular is where things form right angles. So at these corners, you see all these different right angles there. So they're perpendicular lines. Perpendicular lines. And I thought, are they really perpendicular lines or line segments? More like line segments. Let's see what the next question is. Oh, I really like this one. All right, let's zoom into that. So if each cardboard box is 22 centimeters by 15 by 5, what is the volume? The volume. And to figure out the volume, we need to figure out what the base is, the area of the base, and multiply it by the height. So what we're going to wind up doing is we're going to wind up doing all those numbers multiplied together. So 22 times 15 times 5. Now, I'm not going to go through and solve this completely, but there's a couple things I notice about this that could make this significantly easier. First of all, I notice that 22 times 15, those are the two big numbers, and I could switch around the order in which I multiplied things because of the associative property, and that would make it easier. So if I, let's move that down a little bit. All right, so I could change that around because the order of the factors don't matter. So 22 times, and I could just switch around the order of the 15 and the 5 to 5 times 15. So that's a little bit easier doing 22 times 5. But there's one other thing that I know I talk about in my class, where if you have factors in a multiplication problem, the numbers you multiply together, if you have an even factor, like 22 is even, I can half that as long as I double another one. And I notice I double the 5, it becomes 10. So if I half that to 11, and then I double the 5, that becomes 10 times the 15. All of a sudden, that 22 times 15 times 5 has now changed into 11 times 10 times 15. And you know what? There's quite a bit more that I could do in my head that way. And I'm not going to go into what the exact way of solving that problem. You're going to have to go through that yourself. If you need help with that, let's see. I'll just do 11 times 10. I can do that one in my head. That's 110 times the 15. And there's many different ways. I tend to do the area model with my students. This is more or less more of a 4th or 5th grade problem than it is a 3rd grade problem. 3rd graders don't go through volume yet, but they might as well see it. And this is the standard algorithm. So if I multiply that, 5 times 0 is 0, 5 times 1 is 5, 5 times 1 is 5. And I'm done with that part. Because this is actually, that's not a 1, that's actually a 10, so I need to have that place value there. 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1. If I add those together, I get 1,650. And I'm not sure how exactly you're being taught how to do that multiplication. I tend to do the area model. I was doing more or less the standard algorithm that I believe you start learning more in the 5th grade. So keep in mind that no matter where you are, you can certainly find things that are related to math. So if you're thinking about math, you certainly will get better at it. And there's all sorts of problems that you can solve. And if you ever want to build stuff, you're going to wind up needing like a tape measure, rulers, that type of thing. Protractor probably for angles as well. So let me stop this and we can get to our normal lesson. That's just something for you to think about. All right, I got a little bit carried away with actually figuring out the volume of a three-dimensional shape. I tend to do that. I like doing math problems and I like to share neat little tricks that I have. So let's talk a little bit about three-dimensional shapes. So instead of it just being flat like a piece of paper, it's actually 3 dimensions. Now there's some things that we need to go through this. I like to show this because for me it's easier to see it in person. That's one of the reasons why ultimately I hope that you wind up making one of these, and you can make a whole bunch, but there's some things we need to talk about this. So what we were talking about as we were looking at the environment is the volume of the shape. So the volume is you take the base, so basically the area, the base, and then you multiply it by the height. So it's length times width times the height for a cube. Something that's in a pyramid, you're going to have to multiply it by 1/3, but we won't go into that too much. So we have the volume, that's one thing. We also have the surface area. That means I need to figure out what is the area of each face. So each face of the three-dimensional shape. So you kind of need to know how many faces there are. You'd also want to know, instead of length or width, they call these edges. So edges. And the corners, vertices. I sort of interchange vertices, corners. I sometimes mix up if they're plural or not plural. I hope you guys can forgive me. Now, the one big concept that's a little bit difficult, let me get this glass of soda. For those of you who I've taught, you would know exactly what's in here. It's soda pop, but don't let anybody know. So there's 2 different concepts. One's called volume, one's called capacity. The volume of a three-dimensional shape is how much stuff is actually in. So right there's the volume. We could figure that out by figuring out the area of the base times the height, and then we could figure out the volume. The capacity is how much can that three-dimensional shape hold all together. So that stays the same unless you modify the shape. Now the volume can change. Let me show you. I'll show you a neat trick on how to change volume. So the volume went down. I drank some of my soda pop, and the capacity is still the same. Let me show you something now. I find three-dimensional shapes a little bit easier to see them in person in actuality, but there's also, let's see, where is that? There we go. So if we go to this, here is a representation of a three-dimensional cube. So I showed you that line piece of paper that we'll go through, but here is a three-dimensional shape. I could click on one of the vertexes right there, corner, see, another vertex, another vertex, another vertex, so I can go like that. But a lot of the times they'll draw the cube like that. That shows the edges that we really can't see, those dotted lines like that. And then if we shade, we can see the faces, the different faces on it a little bit clearer. And again, I have seen so many computerized versions of three-dimensional shapes. I understand them pretty well. However, I much prefer, let's see if I can get to this. I much prefer actually being able to have something in my hands. It's easier for me to understand. So what we're going to be doing is we're going to be making a cube. That way you can see this. The cube's kind of one of the easier shapes without needing a whole lot of tools. But I need to hook up the document camera, so that's the next thing, and I'll show you the first couple steps. So you're going to need your 6 pieces of paper. You're going to need your 6 pieces of paper. And again, you're probably going to have to press the pause button a few times once we get going. So let me get that document camera set up. 1 second. All right. All right, so you have your 6 pieces of lined paper. The first thing you're going to have to do is you're going to have to make square pieces of paper. That's where all the side lengths are the same. So if you recall, our opposite sides have the same length. So I know that this paper, those are parallel to each other, so I just need to make them all the same length. An easy way to make them all the same length is you just carefully fold it over. Fold it over like that. And then I just mark this. And then if I cut right here, I will have a perfect square. Now you might be going, Mr. Loma, I don't have a pair of scissors. What you can do, this takes a little bit longer, it's so possible. You fold it right on the line, back and forth, and you slowly just tear it. And you're probably going to want to press pause at this point. That way you can make all 6 of your pieces of paper into squares. Because when I start this video, it's not going to be me doing it. It's going to be somebody else. They had a better camera angle than I did. So once I did that, I've got a perfect square. Now you just go, well, I'm going to have to trace and cut that many times. Do you know what? Somebody pointed this out to me. If I was to just take my first piece of paper where I drew my line up all my paper really carefully, especially if I had a piece of paper. If I was to line that up carefully, and then I could cut out all of them at the same time. So at this point, you need to pause this video. You need to make your 6 pieces of paper into squares, because the first thing they're going to say on that video is have 6 pieces of paper. They're going to have colored paper, and then they'll be able to show you how to do all the folds on it after the fact. So get your 6 pieces of paper ready, and you should be good to go. All right, so here's the video. There's no audio, so there's the 6 pieces of paper. Again, you may have colored paper, you may just have the lined paper. Now you should have all 6 pieces of paper as cubes, as squares, not cubes, as squares. So they have to be squares. Once they're squares, then you just follow these directions. And again, a lot of it is just sort of folding it in half.
been working on this problem for so long. I just can't get it right. Every time I try something, it just doesn't work. I keep on messing up. I should just give up.
Hey! We've been alerted to this area because there's a ton of brain growth going on.
What do you mean? I've been failing at this problem.
Your brain has grown so much while working on this problem?
But I can't figure out. I've just been making mistake after mistake. I can't do it.
Exactly. Every time you make a mistake, a synapse fires in your brain. Synapses are connections that your brain makes every time it grows and creates new pathways.
Really?
Yeah, struggle and mistakes and challenge are great for your brain. Your brain is like a muscle. The more you work it, the stronger it gets. And challenging problems are great workouts.
So I should make mistakes and struggle?
Yes, we learn a lot and have a lot of brain growth, especially when we're making mistakes and working on hard problems.
So don't give up, keep going. Some problems go unsolved for years, and that's fine. What's important is how much you learn while you're trying to solve them. Keep taking risks, keep making mistakes.
Yeah, and your mathematical thinking process is super important and awesome. So if you keep learning and making mistakes, that's what's important.
Wow, I had no idea. I'm gonna keep working, and when I make a mistake, I'll know that my brain is growing.
Scientists now know that when you make a mistake, synapses fire in the brain. In fact, more synapses fire when you make a mistake than when you get work correct.
So you mean when you make a mistake, but then you work through it and get it right, your brain grows?
Well, working through a mistake's a good thing to do, but what they actually found was that people's brains grew and synapses fired, even when they didn't know they'd made a mistake. So the study showed that there were two possible synapse firings. The first came when people made a mistake, and the second came when they became aware they'd made a mistake.
But how can a synapse fire when you don't even know you've made a mistake?
That's a great question, and the best knowledge we have on this is your brain grows when you make a mistake, even if you're not aware of it, because when you make a mistake, that's the time when your brain is struggling and challenged. And those are the very best times for brain growth.
Oh, that's so cool. Thanks.
Well, that was a very good video. I know one of the hardest things for me in general is making mistakes. Sometimes I get pretty frustrated with things when I make mistakes, but then I realize as I'm learning, I'm going to be making mistakes. So if you never make a mistake, are you really learning? You're not really learning if you're not making mistakes, because if you know how to do everything right, you basically already knew how to do it. The way you learn something is it's something you don't know how to do, and through the process of learning, you make mistakes. So the big thing on that is making mistakes. It means you need to try. So if you try, you make a mistake, you get a little bit better at it, you try it again until you get it right. So if you followed the directions, and again, you're probably going to have had to press the pause quite a bit so you can catch up to it, you would have a cube. So for your assignment, let me get the assignment on there. So for the assignment, if I can get that on there. Oh, there's the assignment. So the assignment for the second week is to follow along with the lesson and create the cube from the lesson. Take a photograph of the cube and send it to this email. As a reward, the first 20 students to send a photograph will receive materials to make an infinity cube. Now, an infinity cube is something pretty neat, and I will show you that before I wind up leaving. And again, even if you don't turn in this photograph, if you click this link, it will show you how to make an infinity cube. Now, I'm going to warn you, pay attention to this. The first 2 minutes of this video, it shows you how to make really small cubes using glue and stuff like that. You can make cubes that way if you wanted to, but you could also make bigger cubes like the way I showed you. So if you start at the 2-minute mark of the video, so you sort of fast forward and you click where it says 2 minutes, it will show you how to make an infinity cube. So let's get that out. So what does an infinity cube look like? Well, an infinity cube, well, I'm going to have to slide back a little bit. Let's see. An infinity cube is a bunch of cubes that you wind up taping together. And if you see this, like this, here's part of it. I'm having a hard time. So flip, 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 flip. It's a very neat thing that you can make. It's a very neat thing that you can make. And if you follow the directions, you can also make this. Does it take time? Yeah. This takes time to make. Did I make a lot of mistakes? Yes. However, when you think about it, some kids are going to play playing video games the whole entire summer break, not getting outside. If you make this cube, you've actually got something that you can show for and play to. I know I have met many students that actually make these cubes and they use them as toys. And it's a really pretty cheap thing, especially if you use lined paper. You might have a extra folder somewhere where you can actually make this stuff. 6 pieces of paper make this. Let's see, one notebook has how many pages? So you could make, yeah, you could make quite a few of these, I bet. So again, I'm Davin Maloma. This is the second week of the summer learning for all. And you guys have a great summer. Get away from the screen some, get outside and play. It's a good time. Make the infinity cubes. It takes effort. It will be a struggle. You will make some mistakes. However, you'll find out it's worth the time. So, have a good day, good week, and good summer. Bye.